Hi everyone, and welcome to today's SQL Office Hours session. Today, let's imagine you've been asked to solve a problem. You're working on a system which stores students' exam results from courses that they're taking. And what you need to do is map the percentages correct to grades. So we're going to say something like greater than 90% is an A, 80 to 90% is a B, and so on and so forth. So we're going to map those percentages to lettered grades. And in most programming languages, if you wanted to do that, we've got kind of if-then logic. You could write something like this. So the exact syntax always varies depending on whether it's, Java, C, PL SQL, whatever. But conceptually, they've all got some kind of if statement and then if, else if, things like that. So we can assign the percentages to our lettered grades like that. However, if you try and do that in SQL, and we just wrap that in a select statement, what happens? The whole thing falls over in a big heap, right? Why? Well, there is no if keyword in SQL. There is, in fact, no if clause whatsoever. If you want to do if-then logic in SQL, you have to use a case expression. So rather than if, we say have case, and then we have our tests to say which of these conditions is true. So seems fairly straightforward, but there is a lot of details and information to cover on this. So that's what we'll look at today. We'll dive into the details of using case expressions to do if-then logic in SQL statements. So, hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's app dev team here at Oracle, and I'm here to help you get the best out of Oracle database and hopefully have some fun whilst doing so. So with that in mind, let's jump into it. Let's get into the details of writing a case expression. So to start off with, the basic structure of case looks something like this. You have case at the top and then a series of when conditions. And these are tests that we're going to run to check whether or not they're true, and we'll return the corresponding value for the then. So a couple of things to bear in mind with this. The database processes case expressions from top to bottom. I mean, you could write them out left to right, but usually we write them top to bottom on the page, right? So it works down, and as soon as it hits one of these when conditions that are true, it stops processing, and then it doesn't process anything else. Okay, so that's quite important. We'll discuss that a bit more in a minute. If somehow it makes it all the way down to the bottom and none of these are true, we can then fall into this else clause. So else is optional. If you do not provide it, then the case expression will return null if none of these are true. If you do, that's what we'll get if none of those are true. So if we've got our case expression, we wanted our percentages correct. As I said, we want to process it, well, the database processes it from top to bottom. So if you write your case expression like this, so notice we're checking if the percentage correct is greater than 50 and assigning that to the letter E. Yeah, so we do that, and hopefully at this point, some of you can spot the fairly obvious or looming problem with this. 50 is less than all the other values that we are checking here. So if we get any percentages greater than 50, they are going to get assigned the letter E. So none of the rest of those conditions are checked at all. So it's important to kind of check carefully how your logic flows with this. Essentially, instead of doing all the letters A through to F, we've really just assigned E or F right here rather than A, B, C, D, and so on and so forth. So do check carefully. Now you might go, oh, it's not a big deal. How can you get cowed out with like this? We all make silly mistakes. We've all had typos at some point where you've mistyped the criteria here or something like this. But also case expressions can get quite complicated, right? It's not always quite so obvious that conditions are mutually exclusive or overlap in some way. So do take care and make sure that you test carefully and bear in mind that top to bottom evaluation. So that's the basic structure. Now, key thing to remember is there's actually two forms of case expression. There are simple and searched. As the name might imply from the word simple, simpler case expressions are just simpler. They are easier. There's less to them, okay? What we have with a simple case expression is you have case and then a selector. And this selector is just an expression of value. Could be a column, could be a bivariable, anything, any individual thing. And then what the database does is it checks for each of the when clauses, is that selector equal to any of these values? So we're asking, is it equal to V1? Is it equal to V2? So on and so forth. If it's not, we'll get the else if it's present. So this is nice when you've got one value and you want to check it's equal to anything from a list. A lot of the time, however, you've got things that are a bit more complicated than that. So this is where we need a searched case expression. And this is where we can have much more complicated statements. We can say when, and we actually have the full condition here. We're saying that our selector is equal to some variable, or it's less than, or it's greater than, or it's null, and those kinds of things. So simple are more basic, search are more advanced. And one of the big differences with simple is there's always one selector, one thing that we are comparing. So we're looking at our exam grades and wanted to exam percentages and wanted to assign them to lettered grades. We've just got one value that we're actually checking there, the percentage correct. Whereas there might be other things we might want to take into account. Maybe the actual grade boundaries depends not just on the percentage correct, but the exam as well. So different exams have different grade boundaries, which can happen. In which case we need a searched case expression. So even though with our single just 1% correct, we've got one selector, we can't really use a simple case expression because each when is just saying, is it equal to one of those values? So this works quite well if, like I say, you've got a small list of things that you want to compare against. Another small detail, which can be helpful in some cases, is a simple case expression only evaluates the selector once. So we say case, whatever it is, percentage correct, evaluate that once. Whereas with search, we'll evaluate it once for each when clause we check until we find one that is in fact true. This could matter if we've got complicating things. We're calling a function or running some SQL or something like that, something that's going to be slow and take a while. So those are our two approaches here, simple and searched. Next thing you might wonder is, well, what can we actually return here? So those define how we choose which when clause. Having chosen one, what can we actually return from it? Well, we return an expression here, a value. And one important thing to note here is that values must have the same data type. In lots of places in SQL, it will do implicit conversions. So if you compare a number to a string, it will do an implicit conversion if it's possible, or it will try to do an implicit conversion and process it if that conversion is successful. This does not happen with case expressions. They all have to be the same data type. If there's a difference, you'll just get an error. The whole thing will stop. Okay, so there is no implicit conversion in these return values here. And these expressions, they could just be a literal value, 1, 2, 3, a string, something like that. Or they can be a SQL expression, and they can be valid SQL expressions. So could be a query, right? Could return a scalar subquery. Or they could be a case expression. You can actually nest case expressions within each other. That's something that can be quite useful if you start to have quite complex criteria that you're searching against. We'll see an example of how and why you might want to do that a little bit later. So that's the overview of the structure. We've got simple and searched, how we check it. Next thing you might wonder is, well, where can you use it in a SQL statement? And the answer is pretty much everywhere. Not quite everywhere, but pretty much everywhere that you would use a regular expression. So the select clause, the where clause, the join on, group by, having, order by, all those places you can have a case expression. You can also use it in update. So if you're setting a column, you can set it to the result of a case expression. It can be the default for a column, right? So you can use a case expression to assign column defaults. It's pretty widely available in SQL. So at this point, I think that's enough of kind of the overview and syntax. I think it'd be good to kind of actually see this in action, right? And jump into our demo. So let me bring up my demo here. I've got my table, just make sure I build it. And I got my table of exam results, and we got our students' exams and our percentages correct. So the first thing I want to do is actually, I'm going to map these exams to names. So exam ID 1, SQL, 2 is Java, 3 is Python, and so on. So we'll run that, and this is a simple case expression because we're listing the exam ID just once, and then we're checking if it's equal to any of these values. There is no else, so values other than that return null. So we can see we get null for those names. If we want to have a default value that we want to return instead, then we add in the else here, and we say it's some other programming language that we're testing on. And we can see all the other rows get that else condition because they are not these things here. So as I say, these values must be the same type, and we'll see that in a sec. But this is the simple case expression. We're listing that just once. We could turn it into a search case expression and actually explicitly say it's equal to all the things like this. And this is identical to the previous one. It's just less typing, right? In this case, it doesn't really make much practical runtime difference, but it's just easier to type, right? So generally, if you can do it, a simple case expression is just easier, better to use. As I said, these now all need to actually return a string or a number, all the same thing. If we do something like this and have the string 1 and the number 2, the database can implicitly convert them, but it won't do it, right? We will get an exception because they are of different data types. So important thing to kind of watch out for, particularly if you're not just returning static values, you're returning function results or subqueries or something like that. So make sure the types match. So we have our simple and searched, and we can map our exam IDs to actual names. I mean, in reality, we probably would have stored those in another table. We probably have an exams table, right? And this would be our primary key, and we'd have the names. This is just a simpler thing to kind of demonstrate the purpose, show how it works. Let's move on to our percentages, our exam grades. So we're saying over 90% or 90% or higher is an A, then B is 80 to 90, C is 70 to 80, and so on and so forth. And we've also got, if we're less than 50, it's an F. If for some reason there's no marks assigned, it's null, we're going to say that's U for ungraded or something like that. So if we try and do this using a simple case expression, I mean, you can try, right? But we've got to list out all the possible values for the percentage. Okay, this doesn't sound too good, right? This doesn't sound very practical at all. I certainly, even with just 2 decimal places from 0 to 100, there's like 10,000 of these things we need. That's just not great. Also, when you think about this null here, we're checking if percentage is equal to null. Well, can anything equal null in SQL? No, right? The answer is always unknown. So we never actually assign it the grade U. So if we run that and see we've got our percentages correct, our nulls, even though we put null here, we're saying percent equal to null, which is unknown, it's null. So we get nothing. And you can see basically everything is null because it's not equal to any of these values. And I wasn't going to hurt your eyes by listing out all the possible combinations here, right? So we need to use a searched case expression here to check, do the null check, and actually make this something a bit more sane, use range conditions. So we can check if it's null first, and then check our criteria like that. And we can see that now our nulls get U, then we got our everything else, everything less than 50 gets F, and E's and D's and C's and so on and so forth through our results. So that is the basic of our search case. And as I said, the database processes this from top to bottom. So if I'd been a bit slack, uncareful, I'm not really paying attention, and put E first, greater than 50, and guess what? Basically, everyone is going to get an E, right? But you're either failing or you're getting an E, or you get F or an E, which is not good, okay? So as I say, with this, I mean, there's only a small list of things and it's fairly simple criteria. We could probably spot this, but it's easy to make a simple mistake and have the conditions be slightly incorrect. If you want to avoid this and be able to put them in any order, then you need to code defensively and check the upper and lower bound, right? So by checking that they are strictly less than the upper bound, then actually we can stick them in any order we want here, right? So you can see that now we're actually getting all the lettered grades that we expect, even though they're not actually in A to E order, because it has to check all of these. Personally, I think it's just a bit cleaner and nicer to do this, but you need to be careful when there are overlapping criteria. Sometimes you're kind of forced into these more extended versions of search case expressions. So, for example, let's say we've got ID 0, we've designated our test entity. So if it's exam 0, it's a test exam. If it's student 0, it's a test student. We don't actually want to assign them real grades because they aren't real results. They're live testing, right? There ain't no test like a live test. There's something our test team have put in just to validate the process works in production. So we want to filter those out. So we can do that. And notice we can check anything we want. We can check different columns in these, but there is a little bit of a problem here. Okay, so we've got exam student. There is one row here, this row, 6th row here, is both the test exam and the test student. Okay, so 0, 0. But because the database stops as soon as one of these is true, well, it says it's a test exam, doesn't bother checking if it's the test student, so it never gets assigned to that. Okay, so we kind of mislabeled it. We've labeled it test exam when in fact it's both test exam and test student, right? So that's in order to handle this correctly, we would need to code defensively and say that it is the student exam 0 and student 0 first, and that test has to be first. Okay, I've also been very, very careful here and done the not equals to check as well, and so on and so forth. And now you see we've correctly assigned it to be the test exam and student grade that we've assigned here. So someone's asking a question, is E a grade in the UK? I think it depends on the exam exactly. Certainly when I was taking my school exams, they actually went A through G or H, something like that, I can't remember. And there was N and U as well. So there's actually quite a lot of letters available, but it does depend a bit on exactly which exam board you're taking and so on and so forth. Generally, A to C is considered pass. Anything under a C, I mean, technically D and E are a pass, but most employers and so on would look for something at least a C or higher. So yes, it is a grade that's available, typical in the UK, right? Just a bit of trivia for you, right? Learning stuff about the exam student system, or at least the exam system as it was 25 years ago when I was at school, right? Things probably changed a little bit since then. Anyway, we've had to code quite defensively to make sure we've tested our exam student correctly. Now, rather than doing that, what we can actually do, as I say, is nest case expressions inside each other. So we could do first a check and say, is it not the test exam and student? And if so, assign it the letters. So this is, if it's not a test row, we're going to give it the correct grades. And if it is otherwise, we will assign it, we'll tag it with the appropriate test. Now notice I'm chaining actually the case expressions together here. So I've got individual criteria to test them. Is it a test exam? Is it the test student? And so on. So we'll run that and we can see we are assigning test exam student correctly, but it is slightly different to what we had before. Before we had the kind of grammatically correct test exam and student. Here we've just got test exam student. So this is where you've got to think about what output you want and so on. If we want it to say test exam and student, we actually have to do some quite funky processing in here and so on. If we just want to tag them and say it's a test exam, test student, then this might work. So you've got to think a bit about what output you want as well when you start chaining them together. The key thing here is as your search criteria gets quite complicated, particularly if lots of them can overlap, it can be quite useful to nest case expressions inside each other and then kind of chain them together to concatenate their output. It's not always practical or possible, like I say, but when it is, it can make it just a lot easier to debug and figure out what's going on. Okay, so we've got our more complex conditions and we've been assigning them in results and we've just been getting our output. So each exam, what grade people got. And for kind of distributing grades or just producing charts and so on, that's probably good enough. But we might also want to do some filtering, right? We might want to say, show me all the students who got an A or a B or whatever, something like that. And in order to do that, we can actually use the case expression in the where clause, right? So we're saying is A, I mean, real application, this would probably be a bind variable, right? I'm just using this to make it a bit clear what's going on here. And we are comparing that to the result of the case expression. And you can see we've just got all our A grade students who got 90+% correct. So this kind of does the job, but it can get a bit kind of complicated. Let's say we want to find everyone who's got an A to C, which I say in the UK is generally considered to be a pass. But we want to filter on that in the where clause, so we can say the case expression in, but of course we probably want to see the exact grade in the results as well. So we are actually duplicating the case expression, right? So we've got it listed twice here. So we've got it in the select and the where, and we can see we've got our A to C grades, but we've had to kind of do something a bit mucky, right? And copy paste our code, which is not great. Problem can get more accentuated if we start doing things like grouping and ordering. Let's say we want to count the results per grade. So we can have the case expression in our select, then group by it, and then order by it as well. So we've in fact listed it 3 times, and maybe we want to have a where clause where we filter on it too. So again, this gives us the results we want, but this is even messier again, right? Now, fortunately, when it comes to order by and more recently group by, we don't actually have to repeat it. We can use the alias here. So we can assign the value in the select, use the case expression there, and you've been able to order by an alias forever. You know, I don't know when it came in, a very, very long time. Group by alias is something, this is new. This is in 23C, the new release that's out. I'm using the developer release, so the 23C free developer release, which is available now for you to get out, download and use how you want. Expect to hear more about 23C if you do come to Cloud World. But group by alias is new in 23. Order by alias is available for a very long time. Nice thing here is we only need to list this out at once, right? But it's still a bit of a faff if we want to filter on it, have it in the where clause, something like that. So, and it has been individual to each individual SQL statement. If we've got lots of statements that we want to do, get this result on or filter on it, we're copying code, right? Or which is not ideal. Now, a good way to make this reusable, we could create a view, but I think it's better to actually make this a virtual column. So we make the case expression, the result, the virtual column, the result of the case expression, and then we can just list that column in our select and our statements. So now it greatly simplifies it and makes it reusable and available however we want. If you want to see what it is, you look at the data default and the tab cols views, you can see there's our expression listed out there. So top tip, if you've got a case expression doing something like this and you are likely or need to use it in many places, make it a virtual column, if it's possible to do so, of course. So question come in. It looks like a case statement in the where clause could have a significant impact on performance. Correct. Yes, very good point. One thing to bear in mind here is, of course, that when we've just got it in the where clause like this, by default, at least, the optimizer doesn't really know what it is, right? It doesn't, like, it's not an individual column, so it can really struggle to estimate row counts accurately. If we turn it into a virtual column, it can gather stats on it, which can help from that perspective. You can also create an index on it, which can help even further. But there is potentially still an issue if this is not just a regular column, right? It's a function or a subquery. Sadly, you can't really make those virtual columns. There's limitations about making those virtual columns anyway. But yes, you do need to think about and consider it. And in those cases, you might have to think about, do we store it in the table? Something like that. But yes, again, it's one of those things you've got to analyze on a case-by-case basis and figure out what your requirements are need. Have you hit a performance problem, and what's the best way to solve it. Okay, and so we've got our virtual column, we've got our results, and we can see it and we can reuse it. Any other questions or comments on this before we move on? So we saw the basics of using a case expression. Database evaluates it top to bottom, picks the first one, and returns the corresponding expression. We can use it throughout the SQL, select from, not from. Can't use it in from. That's one of the places you can't. You can use select, where, order by, and so on and so forth. And for reuse, we can make a virtual column. I'm going to ditch the virtual column just to, otherwise it will clash with some of the later examples I've got, right? But like I say, I would, something like this that we're going to use a lot, I personally would very strongly consider making it a virtual column. Alrighty then, if there's no other questions or comments, again, let's just kind of recap on that. Again, we saw simple versus searched. Simple, one selector, check if it's equal to any values. Searched, we can have very complex search criteria conditions we're checking. Evaluates top to bottom. For something with a few values, it's probably, you could probably just look at it and check it's okay. As you get more complicated, it becomes very, very easy to have overlapping criteria and not spot it or make logic errors. In those cases, nesting case inside each other can be quite a good way to help simplify, or at least make it easier for you to understand what's happening and debug and deal with what's happening as a result. And in terms of where you can use it in a SQL statement, pretty much everywhere you can use a regular SQL expression. Select, where, order by, group by, column defaults. When updating a column, set it to the result, and so on. So first up, we were asked to map the percentages corrects to lettered grades, A to F. Let's tweak the requirements. You've done this and you go into your boss or whoever and they go, here you go. And what's the first thing they do? And they go, oh, that's great. You need to do this other thing as well. Okay. Not only do we want to return the letter, we want to tag them as being a pass or a fail. As I said, generally speaking, in the UK, A to C is considered a pass. Anything under that is considered a fail. It's not strictly, but certainly employers would always be looking for C or higher as exam results for English, maths, that kind of thing. So we've got two values that we want to return here, the letter and pass fail. So you might try and do something like this, have our one case expression and return two values here. Unfortunately, you can't, right? You can only return one expression in each when clause. So what do we do here? How do we get around this? Well, there's various approaches. Perhaps the most obvious and probably the worst is we just duplicate the whole case expression. So we have the case expression for the letters, copy paste it, and then just change the letters to pass fail, right? Does the job, but we're duplicating code, and hopefully I don't have to spend too long explaining why that's not a great idea, right? So I wouldn't want to duplicate things, right? Well, what else can we do? Well, rather than trying to return them as two separate values, we can actually return a complex type. We could turn it into JSON or XML or an object type or something like that. So it's one value still, but it contains both the information. And this can work quite well because we're still just returning one expression and it contains everything we need. The big difference here is, of course, instead of two separate columns in your SQL results, it's JSON or it's XML or whatever it is. Whoever's consuming that data needs to know and understand that structure. Hopefully not too big a deal. A lot of tools will have inbuilt support for JSON and XML and so on, but still it adds a little bit of complexity, right? And it may not suit your particular needs. So what if we do want them as actual proper relational columns? Well, the thing to do here is actually have a table that returns both of the values we want, the letters and pass fail, and join the case expression to that. So I'll show an example of that in the demo in a bit later. So we can, if we want to have a type, we can say these are JSON objects with grade and outcome. And so the client needs to understand that. Or you can, just like you can use the case expression in the where clause, you can use case expression in the join clause. We can actually join to it, join a column to it. As we were mentioning a minute ago, in terms of how is this in terms of performance and the optimizer, it can be struggle, right? The optimizer might struggle to find the best join method and plans, things like this. But as I say, wrapping this in a virtual column, allowing it to gather stats, create indexes, and so on can solve that problem, should you wish to do that. So we can, if you need to return multiple values, use a complex type, JSON or whatever, or join it to a table which has all the columns that you want in the result. So let's move on and then tweak the requirements or do something a little bit interesting, a little bit funky. Let's say we want to do kind of like a dynamic search. So we want to search on either the grade, the letter, or pass-fail, one or the other, not both. And actually what we'll have is a variable which tells us which of those things we are going to be searching on. So we want to compare a different column depending on a variable. Now, you can actually do dynamic joins like this in SQL, right? Because a case expression can return any expression, and columns are just expressions, you can change which column it returns. So we've got our case, our col selector. So this is our variable, and it will say, grade or outcome or whatever, O or G, whatever we want to call those, and then change which column we are returning based on the value of this input. So this is something you can do, but I would strongly recommend that you never ever do this, right? I've been asked this. I mean, I'm not asked this all the times, but it's cropped up often enough that clearly some of you have either thought it was a good idea or felt been forced into doing this. Personally, I think it's just not, this is a bad idea, right? It's hard to debug. It's hard to figure out what's going on. It makes things even harder for the optimizer to really understand what's the best way to execute the SQL statement. Unless you're forced to do this, maybe you're dealing with a third-party system, or you've got you're provided the values and you've got no say over it. I would avoid this at all costs. If you have a good reason other than, and I'm forced to because the spec told me to, or that's what we had to interface with some legacy system or something like that. Those are just life you've got to deal with, right? I don't consider those good reasons. If you have a good reason for doing this, I'd love to hear it, because personally I think this is terrible. But like I say, I'm just explaining it because I know people have asked this, and so just showing that is in fact possible. So you can do dynamic joins with a case expression, change which column you're returning and join that to a single variable, but I would strongly advise you not to do that. Looking at another kind of and more advanced use case. So before we were filtering on pass, fail, or grade or something like that, what we might want to do is actually have columns in the output and count for each exam the number of passes and the number of fails. So get something like that looks a bit like this. So we've got a table or a report, we've got our exam, how many students passed, how many students failed. So how can we do this? Well, we're going to count things. The key here is we want to put the case expression into the function call, right? So we've got our case, we're counting the result of the case. Now, the interesting thing to note here is, and we're checking whether it's whatever criteria it is for pass or fail and returning a value as appropriate. Key thing here is there is no else clause. So it will either be for pass or it will be for fail. So we'll have two of these expressions, and it will return null if it doesn't match that, okay? And count only counts the non-null values, okay? So this will give us how many rows were a pass, how many were a fail, or how many were a particular grade, depending on what we wanted to check there. So we can use this with count. You can also do any of the aggregate functions, all work in the same way: sum, average, mean, max. They ignore null values. Key thing here is you test the one thing that you want that column to return, and if it doesn't match that, you return null. There is no else clause, so we ignore the results. So you might want to turn the average passing grade or the average fail grade, that kind of thing, and so on. We can do things like that. So this works, but it can be a bit fiddly. As I said, if we want to count the passes and the fails, we actually need 2 here. They're not quite a duplicate, they're just the opposite of each other, but we are writing things out multiple times. An alternative is you can actually put the case expression in a subquery and then pivot on the result of it, right? So we're pivoting, we've got our case expression, which will say the outcome pass or fail, and then pivot to count those values. And it will generate a row for each of those values that this case expression returns. So this, convert those rows into columns. Very common requirement. This is something that comes up super, super often. So at that point, that's enough of like syntax and stuff. Let's just, again, show this in an action, actually see how it works. So we dropped, and yes, I did drop the exam because that will break some of my demos later if we don't do it. Alrighty then. So let's start off with returning multiple values. Again, we're trying to return 2 things. It doesn't work. We're going to get an exception. Okay. So if we want to return pass and fail, as I say, we can duplicate the logic like this. So we've got 2 case expressions, there's 2 columns, and there we go. I mean, arguably, of course, we could simplify this. We can get rid of these. We can just say pass. We can just reduce it down to this. It's a bit better, but there is still a relationship between these, right? If the boundary for a C changes at all, we're changing it in 2 places. So, ultimately we are duplicating the logic because there's a relationship between these values and these values, right? So this isn't great. All right, so let's return it as a JSON object. Again, I've just picked JSON because everyone, it's what all the cool kids are doing these days. Could be XML, could be any format you like, as long as it is one expression that we are returning. And you can see there we've got our grades and our outcomes. And then it's up to the client, whoever's running this query, to understand, no, this is JSON, and then interpret it or process it appropriately, which is probably the drawback of this, is you need to kind of have a bit more agreement. And then if it's just a regular SQL query, probably, okay? Because of course, we might change your mind about what these are called and so on and so forth. So let's join it to a table. So here I'm actually just, I'm not a table, I'm just generating a value on the table on the fly by selecting the grades and the pass fail. And as I say, we are putting the case expression in the join. So we can see that is what we had there. And then it joins to this grade here. So we can see the grade matches that case expression. We get our results. So we get pass fail as our outcome. Again, do be careful about performance and things like this. Alternatively, you probably would actually want to create an actual regular lookup table, and we could store some extra information so we can have our upper and lower bound. If you're wondering about these constraints, my unique constraint and the foreign key to it, well, that's to ensure that the upper and lower bounds always equal each other. If you want to know more about that, you'll have to watch the recording from the advanced session I did on constraints earlier this year. Back in March this year, I explained how you can use these constraints to ensure these values are all consecutive, ensure there's no gaps in between them. So that's what those constraints are about. Check that out. It's too much to explain to you now, but if you want to know more, check out the recording of that. So we've got our data in there and our grades, and again, we can just join to a proper table, right? In this case, we can get our results and we get our pass fail outcome, and you can see the upper and lower. The advantage, of course, of making it a real table is, as I say, we can add other columns. This is now data driven. We can create some user interface on top of this table and allow the end users, the exam administrators, to change these values as appropriate, and so on and so forth. So we can do it like that. Another thing we could try and do is, rather than using a case expression like this, is essentially move the logic from it into the join clause. So we can do something like this. Now notice this is a bit complicated, right? If it is a complex case expression, turning that into a proper join, a regular join, just using, equals and quality and things like that, could be even more complicated. So which is the best approach here? You've got to decide, right? You've got to figure out what works for you, what results you need, how are you going to manage this, and so on and so forth. So there are various approaches here if you want to return multiple values. So we've got this quite complicated query where we've got our case expression. To make it reusable, I'm putting that join in a view. So we can now reference that view, and we can see we got those columns in the output there. Very nice, very useful here. So then I wanted to say, move on to this dynamic filtering, something I kind of hate, but like I say, I'm just doing it for completeness and knowing people have asked for it, and just make the point that I don't like this. If you've got a good reason for doing this, please share it, because I'd love to hear it. Okay, but basically what we're saying is, depending on the type of search we're doing, we are going to return a different column and compare that to a different value. So let's see we want a G for grade, and we're going to compare that to A. So grade A, we'll get our grade A results like that. And you can see we just got our grade A's in the output. Alternatively, we can say O for outcome, pass, fail, and let's return all the failures, if I can type it right. Fail, and we get that, and you can see we've done that. So we have got a kind of like a dynamic join, so we can use the case expression to change which column we are joining on. Personally, I can't think of a good reason why you do this though. If you have this, I mean, like I say, you might be forced to. You might be that whatever the client sends you is just kind of some kind of indicator value, and then or type value variable to tell you what is in the value variable. It's just a general programming principle. Having one thing mean two things, generally bad idea, right? It'd be better to do something like this, if you need this kind of dynamic searching and filtering. So if we want A grades, we can do something like this, find us just the A grades, and if it's null, remove that, return our failures, again, typing correctly. This would be better. This does rely on both grade and outcome being mandatory columns. If they're not, we need further null checks in here. Or you could just use regular dynamic SQL to inspect these and construct your SQL statement as appropriate. If you have any questions on that, please just put them in the chat or in the comments. Please let me know. But let's then move on to our filtering in aggregates. Okay, I see something's come in. If I want to be able to redo grades after a time because D is passed from a given date, then should I be using a table with the date active? So that's a good question, right? So basically, let's say we've done something like this. We've got our exam grades and we've changed our mind. D was a pass, D was a fail, but now we want to reclassify it as a pass. Or maybe we want to change those boundaries. So the first step is, by having a table, we can then, allow the exam administrators to change that themselves. But as soon as somebody updates this table, then the query returns a different result. So this is where you need to think about what's the end requirement here. Do you need to always report things as they were at a particular time, right? And say, on date X, we got result Y, or is it in fact just a mistake? Should D have always been considered a pass? If you always want things as is, as they are now, and don't care about the history, then you can just do something like this. If, however, you want to say that in the past, we assigned D to be a failure, and now we've changed our mind, is in fact a pass, then yes, you would need to do something like that. You'd have to have you could change your case expression, say when the date, check the date is in there, something like that, or have a column in the table and filter on it. It's getting quite complicated. Maybe if you hang around at the end, we might look into that in a bit more detail. But the short answer is you can't put it in the table. You can do something like that. Exactly how you go about it really depends on your own requirements, and again, can get quite complicated. And sometimes it might be easier or better just to store it directly on the table and allow people to update it, right? But if we've got time at the end, we can discuss that in a bit more detail. All right then. So we had our dynamic filtering, nothing else, no other questions coming in at the moment. Let's do our columns, so our pass, fail, count columns. So we've got our case expression inside the count. So greater than 70, C or better, is a pass. Under 70 is a fail. And again, notice there is no else clause. I'm just returning 1. It can be any constant here. It just has to be something not null, so that count can count it. Okay, and we can see we get our output like that. So we get our case expressions. We can also, as I say, you can do the averages, min, max. So rather, we can say for the people who passed, what was their average grade, average percentage? For the people who failed, what was their average percentage, and so on and so forth. What was the minimum, maximum passing percentages? And you can see these passage percentages are all between 70 or more. Okay, so if we want to do conditional aggregation, you can do things like this. We can also use it to generate columns for the letters. So rather than assigning them for each one, we can have columns to say grade A, B, C, D, and so on. So we run that, and we get our output like this. So we've got our columns in the output. And this kind of does the job, but it is getting quite fiddly. We're not quite duplicating the logic, but it's pretty close, right? You're having the case expression appear multiple times, and there is a relationship between them. It can get quite easy to make a silly mistake in this process and make an error so they overlap or there's a gap or something like that. It'd be better if we just wrote one case statement and then counted the result of that. So this is getting easier. So we're saying, talking about pivots, we have our subquery, which does that assignment, and then we will pivot on the result. So we're going to count for our grades, and we'll get A, B, C, D, and so on and so forth. So in general, certainly if you've got multiple of these columns, personally, I would prefer to use a subquery and pivot. You can go this kind of old school way if you want to do so, but it can get a bit tricky to maintain. So we can use pivot, we can return the count. You can actually return multiple aggregates. So we can say the count and the average. So we've got our case expression. In this case, we just want the number and average percentage correct of people who passed. So we've got that in our pivot clause. We can see we get those two results there. Notice, even though we've got fail in the outcome, because we haven't listed it in this in clause, it's excluded from the output, right? So we can have our case expression with all the different values here. We only get a column for the values you list out down here like this. So very useful. Like I say, I know a super popular requirement, converting rows into columns, is have our pivot here. And when we want that complex criteria, rather than sort of duplicating it, but not really, just list it once in our subquery. Finally, one other thing we can do, we talked about using case in aggregates. We can also use them as window functions, right? So what I'm trying to do here is say, how far from the average passing percentage was each person's percentage, right? So not from the overall average. We say the average pass mark was, we can see passing percentage average was in the high 70s for most people, right? How far away from that was each student? So maybe we can figure out who needs more attention or something like that. So again, we can put the case expression directly in the window function, and we just got our over clause to split it up by exam. So we get the average, and we can do that to subtract and get the difference there, gap to the percentage, pass, fail, whatever. So the key thing here is you can put case expressions as arguments to functions, in particular aggregates or analytics, to do kind of conditional sums, conditional analysis, conditional means, that kind of thing. We covered quite a few things there, right? We looked at some of the more complicated use cases for case. One is if we want to return many values. Short answer is you can't. You've either got to duplicate your logic, not great. Use a type such as JSON or XML or an object type to return all the things as one value, or we can join to a table. Of those other two options, which you use kind of depends on your use case and what you need the results as, right? You can use case expression to do a dynamic join and change which column you join or filter on. Again, I think this is a bad idea, so let's move on. And then you can do conditional aggregation and window functions by putting the case inside count or inside sum and things like that. That does the job. A lot of the time, it's actually better to put the case expression inside a subquery and then call that either as a pivot or just as a regular column in the outer query. But that is available to you if you want to generate columns which have kind of conditional processing logic. Right, finish up. And we talked a lot about SQL, but here at Oracle, we've got PL SQL as well. So some of you might be wondering, well, what about case in PL SQL? Are there any differences between case in SQL and case in PL SQL? Short answer is yes, there is. A lot of them are kind of subtle, but there are a few things which are a bit more foundational and important to be aware of. First, this is kind of a small thing and kind of thing which, in theory, hopefully none of you will ever actually encounter because it's just crazy code. PL SQL has a check to ensure that at least one of the values returned is not this constant null. If we've just listed null for all the whens and the else, you'll get an exception, an error. PL SQL will go, you're always returning null here. What are you doing, right? SQL does not do that. Now notice it has to actually be the keyword null. If it's just a variable that happens to return null, PL SQL won't detect that. But it's a nice check, but probably one you'll never encounter because if you're writing code like this, you probably need to think about your your programming decisions. Why are you even writing this in the first place? Right. Anyway, so that's a little thing. Another kind of small thing, but again, more subtle thing to be aware of. I said that case in SQL does not do implicit conversion. Case in PL SQL does, okay? So it's a small thing and in theory shouldn't matter, but you find yourself copy pasting case expressions between SQL and PL SQL, you might run into this and kind of end up with errors or unexpected results. So PL SQL will implicitly convert the return values, SQL will not. Okay, so again, another small thing, which you're more likely to encounter this. The other, now moving on to something that's a bit more important, a bit more foundational, and that is PL SQL has another form of case, and that is a case statement. So far, we've been talking about case expressions. Case expressions always return one value. They resolve down to one thing, which is the result. A case statement, each when clause can run one or more actions. So it does something, right? So case statement is more analogous to an if statement, okay? Another important difference between these, with a case expression, if nothing matches, the whole thing just returns null. With a case statement, if nothing matches, the database will raise a case not found exception, right? It will tell you, you tried to do something here and we couldn't find a match, didn't work, right? So case statement is where you really want to say, I want to do one of a number of different things and make sure I want to do exactly one of them. And if I don't do one of them, tell me because there's a problem, right? This is the other thing that makes case statements different to a series of if-else-if statements. If you've got a series of if-else-if statements and none of them are true at the end, the database doesn't care, right? If you've got a case statement and it gets all the way into the end and it didn't do anything, then it will give you case not found. So there is, a subtle difference here between if, else-if, else-if, and case when case statements. So how do you identify the difference between an expression and a statement? Well, again, this difference is little bit subtle. You look at the very end of the the case, it has the keyword case, right? Whereas a case expression does not have that case. In fact, if you did that, it's considered an alias. Or is it considered an alias or a keyword? I can't remember now. I'll have to double check that, right? But also we're returning doing statements, so calling procedures or assigning variable values, things like that. So we are doing things here and we can do lots of things. It doesn't just have to be returning one value. We could run a SQL statement, call a procedure, call a function, so on and so forth. Okay, so case statement does actions. A case expression returns one value. Okay. So again, if you want to avoid getting the case not found, then you need an else clause here. If you've got no else in a case statement, you are at risk of case not found, which might be what you want, of course, right? You might want to know, we tried to do a thing, it didn't match anything, tell me, right? But a lot of the time you probably don't, okay? So another thing to be aware of. So that's kind of a foundational difference or additional feature of SQL's case statements. Let's move right back to the start where we started with this assigning percentages to letters, okay? And as you can see, we've duplicated percent correct here, which is getting a bit messy, right? It'd be nice if we didn't have to do that, right? It'd be nice if we could kind of simplify it. So we only actually listed percent correct once, a bit like a simple case expression, right? Kind of cool if we could do that. Well, the good news is in 23C, you can, right? PL SQL has extended simple case controls. So we can have one selector in what we call a dangling predicate. You can see basically it's half a condition. So implicitly, we're saying when percentage correct, and it is implicitly listed on next to the when clause here. So we're still checking one value, but we can have different conditions, not just quality. We can say greater than or equal to, and so on and so forth. So you can do is null, in, greater than, less than, between. You can actually chain them together. You can look carefully. I've got a comma here where less than something, greater than, or greater than something. If either of those are true, have the end value. So this is an enhancement that has come in 23C. This is PL SQL only, all right? Hopefully it'll come to SQL one day soon, but currently it is PL SQL only, and it is in 23C. So that's enough kind of talking about that. Let's move on to the demo and just show those. So again, just to kind of make the point about implicit conversion, this is not going to work in SQL because they're different data types. However, run it in PL SQL and voila, it goes ahead and actually executes. Looking at a case statement, notice we've got end case here, and we're saying return two values. Well, we're assigning two different variable values here, grade and pass fail. So we've got our case statement and it runs away and we get our results so we can see whether things are pass and fail. As I said, we've got no else here. So anything less than 50 are Fs. Won't be processed, and we get the case not found, right? So do we want that? Do we want to know it? Do we want to trap it? How do we want to handle it? You need to think about that and handle it appropriately. Do note, however, case not found is only case statements. Again, if we have a case expression in PL SQL, this, we've got things that are not A's, they just return null, right? So do bear that in mind. Again, at least one of these has to not be the null value. Again, I'm not quite sure. Maybe, I guess mocking things out, you might have started writing something like this and forgotten to update it. But otherwise, it's nice to have this check, but hopefully you would almost never actually encounter it. And finally, let's move on to our extended case controls, right? Notice we've got percent correct listed once here, and we can just list our things out. So simple case expressions, but with more powerful comparisons. As I say, we can do all sorts of things here. Maybe if they get 100, we say they're an A star. Everyone who got exactly on the boundary, we're just going to say boundary here for now, greater than. We're going to check for nulls or zeros, those are U's, and so on and so forth. So we can have more complex criteria. However, it is still just against one value that we have there. All right. And that was it. That was it for PL SQL. So there are a lot of nice little enhancements in PL SQL, which make it subtly different to how it works in SQL, case in SQL. Recap those. So as I say, the return, there's a check that at least one of them is not the value null, and it does do implicit conversion in PL SQL. SQL does not. It gives you an error. PL SQL adds case statements, which are much more like an if-else-if series of if-else-if statements, but not quite, due to case not found. And then in 23C, we have extended case controls, which are a really great way to simplify these things where you've got one selector and kind of more complicated criteria to check it against. I'm going to wrap up now, but if you're going to hang around for questions at the end, you're welcome to. So we saw with case, there is no if keyword or statement in SQL. If you want if-then logic in SQL, you've got to use a case expression. We can solve the simple and searched, and the database processes them top to bottom. So think carefully and make sure you've got the order of processing appropriate. Code defensively and nest case expressions inside each other should you really need to. In terms of more advanced use cases, if you can't return many values in one case expression, so you've got to duplicate it, return a JSON, join to a value, things like that. We can do like dynamic where clauses. That's getting into kind of dodgy territory, if you ask me. And you can put it as the arguments to aggregate and window functions, count, sum, average, min, max, and so on, to generate columns with conditional filtering. And then PL SQL has some nice little improvements, enhancements to case, such as case statement, which do actions and extended case controls in 23C, which are, again, I think are really cool. Nice little thing that are really cool to use. If you want the scripts from this, I know everyone's always like, can I have the scripts? They are available, so I'll leave this up for a second. They're on Live SQL. You can just access those and download them, play around however you want. Live SQL is still on 19C, so the 23C features will not actually work there as is, but hopefully that will be upgraded in coming months. But in the meantime, you can get it download 23C yourself. As I said, there is no office hours next month because I'm in Vegas, baby, right? I do hope you're able to join us to learn more about Oracle Database, what's in 23C, and even some of the older, longer standing stuff, which you may not have used. If you are there, I'll be wandering around. Feel free to grab me and have a chat and talk about things. So with that in mind, all that's left to say is our next office hours will be in 2 months' time, so 17th of October, because I'm going to be in Vegas when we normally land, when this would normally be. So otherwise, I'm just going to say, really hope you enjoyed this. More importantly, I hope you learned something. Hopefully see you in Vegas. Otherwise, I'll see you here in October. Goodbye.